of location. The great philosopher Immanuel Kant divided fields of study up on the basis of the subject of study, things like biology, studies living matter, geologists study rocks, but two fields take a somewhat different approach to their object of study. One of those is history, which focuses on time as a main theme, and the other is geography, which focuses on place, location, and the relationship of one place to another on the face of the earth. Now, for most of human history, this has not been a critical factor because most people didn't travel very far. They could see to the other end of the valley, or they could locate themselves in terms of 2 days travel down the river or over the pass into the next valley. But when people started to travel long distances, particularly by sea, then this whole notion of where you are and how to determine where you are became much more critical. We can trace the efforts at trying to do this back at least to the time of the Greeks, probably even further. But in classical times, Greek and Roman times, most sailing, certainly in the Western world, was coastal sailing. People would move along the coastline, often stopping overnight, not sailing at night, rarely getting out of sight of land. So it was really only with the advent of the age of exploration in the 16th, 17th century that it became necessary to develop a more precise way of locating where people were on the Earth's surface. Now, one of the problems, of course, is that the Earth is a sphere, and we're not used to thinking in terms of spherical surfaces. Mostly we think in terms of a flat plane. And of course, when we translate the surface of the Earth onto a map, we are translating something that is curved onto a flat surface, which provides some distortions, but that's another issue. We won't deal with that right now. But how do you locate things on a sphere? Most of us, I'm sure, are familiar with a simple grid where you've got a vertical axis and a horizontal axis and numbers along on each of these, a grid layout, and you can mark something on that grid, look at the numbers on the vertical axis, the horizontal axis, and identify a particular location. But that's on a flat surface. On a sphere, it gets a little tougher. If, for example, I were to give you this ball and point out that it has a red dot on it, and then ask you to tell me to describe where on the ball that red dot is, you would have a very hard time. Because on this sphere, there's no reference point. There's no place to start from. Now, when we locate things, we almost always start from some known location, frequently where we are. If someone were to come up to me on campus and say, where's the bookstore? I would probably say, well, we're here. If you go down this hallway to the end of the building and turn right and go out the door and turn left and go about 100 yards, you'll come to it. Now, when I'm giving its location, I'm giving them a sequence of information. We're starting from a known spot, where we are. I give them a direction. In this case, I say go down the hall, but I could say go east or whatever it happens to be. And some idea of the distance to the location that they want to know. Well, we can do the same thing on the Earth, but we have to have some reference points to start with. Now, as it happens, we do have some built-in reference points when we're looking at the Earth. Now, remember that the Earth is a sphere, and it rotates on its axis. Every 24 hours, it makes a complete spin. That's how we define a day. It's the time it takes the Earth to rotate completely around. What that means is that the two poles, the north and south pole, then, are fixed. Any observer would identify these as the same location. So we have two reference points then, the north and south pole, for measuring from to locate things on the Earth's surface. Now the problem with the poles, of course, is that they're kind of at the ends and not very convenient, and in areas where there aren't any people. So for convenience, what we've done is to arbitrarily take a point exactly halfway between the poles, draw an imaginary line around the sphere of the Earth, call it the equator, and we measure from there. So we can then indicate where a particular spot on the Earth's surface is in terms of its distance north or south of the equator. And remember that locations on the Earth's surface are measured in degrees, 360 degrees to go around a circle. The distance from the equator to the pole is 90 degrees. And so we can locate any place then as being somewhere between 0 degrees at the equator and 90 degrees north, which would be the North Pole, or 90 degrees south, which would be the South Pole. Los Angeles, for example, is located at about 32 degrees north latitude. Now keep that term in mind because we will be using it a lot. Latitude is one of the very basic locational references for looking at things on the Earth's surface.
Your slides. Okay, save it to your YouTube account.